Hey guys, thanks for watching the video. Today we're going to be talking about a dual duct HVAC system. This type of system uses two sets of ductwork for the distribution of heating and cooling. One set of ductwork will be for the hot deck for heating, the other will be for the cold deck for cooling. That you need to remember with this system. For one thing, each of these sections, whether it is the heating or whether it is the cooling, work independent as far as trying to maintain a temperature. For example, we can be in the middle of summer where all of the boxes are calling for cooling and still have a hot water valve wide open calling for heat, trying to warm the hot deck up to its temperature set point. The same is true in the wintertime when we're not calling for cooling, but we will see the chill water valve open and the cold deck trying to cool. The reason for this is each of these two are basically their own independent system. They want to maintain a particular set point. The hot deck wants to maintain a particular discharge temperature, and the cold deck wants to maintain a particular discharge temperature. There is one supply fan between these two sections. The supply fan provides air for both. Now, to provide temperature control, whenever you get into the individual zone, the thermostat is going to give the reading back to the main VAV controller. Now, if the VAV sees that the room needs heat, it will open the hot deck damper and close the cold deck damper, allowing the space to heat up. If the space is too warm, it will do just the opposite. It will close down the hot deck and open up the cold deck and allow the space to cool. These systems can be a bit complex at times, however, they can provide adequate heating and cooling for spaces. One thing you need to remember, however, when you are in the middle of summer mode and all of the boxes are closed down to heating, because there's very little need when we're in a lot of the warmer months for most buildings. One of the things that we can see is an extremely high pressure inside the hot deck ductwork. The same is true in the wintertime for the cold deck. When we're not calling for much cooling in the buildings, we can see higher pressures inside the cold deck ductwork simply because the VAVs are backed off on the cold deck side. One of the things that happens in this type of situation, depending on whether the air handler is set up to run as a high select or a low select system. For what that is, basically your pressure inside each of these ductworks basically will be what controls the speed of your air handler, of your supply fan. If it is a high select, the supply fan is going to run and ramp up until the highest of the two values reaches set point, whether it is the hot deck or the cold deck. Whichever one is the highest value will be the point at which the supply fan will try to maintain. If it is a high select, one of the things that can happen is that you will get a low amount of airflow into the side which is being used more. You can run into a starved box scenario with this, where you do not have enough air supply for adequate heating or cooling of the space. A low select control is where a system will control based upon the lowest value. Whichever one of these two specific pressures are the lowest, that is what the air handler will try to maintain. Now, one of the problems with this is if you have all of your boxes on one side, whether it is heating or cooling, closed off, you're going to throw the pressure real high in that set of ductwork. The air handler is going to continue to ramp up to maintain its specific static pressure set point on the low side, regardless of how high the pressure gets in the high side. One thing that happens in this type of situation is that the air handler can trip on high pressure, or you can damage ductwork. That is where engineering is key in designing a system that can handle this type of scenario. Anyways, I hope this helps to give you a basic understanding of the functions of a dual duct HVAC system. For more on these topics, visit my blog at systemcontroltech.com, and thanks for your time.